Hello, everyone, and welcome to the very first session of our UE Systems Seasons of Reliability Fall Live event series. I'm Brittany, and I'll be your host today as we kick off this series with the topics that's equal parts spooky and spectacular, from tricks to treats, ultrasound case studies that save the day. I know you don't know a lot about me, but this time of year always brings out two things: a love for candy and a good comeback story, and that's exactly what we're going to hear about today, from close calls to mystery noises of what's that sound, different things that can go horribly wrong, but didn't because somebody used the power of ultrasound. We have an amazing panel here for us today to kind of give some behind the scenes stories. But before we get rolling, just a couple of quick notes. Drop your questions or reactions in the chat. We'll be keeping an eye on those comments throughout. Don't be shy. This is meant to be an interactive event. So if you have any questions or if you want to talk or respond, please feel free to do that. We'll all be communicating in there. And yeah, let's go ahead and jump in with some reliability tricks into the real world treats. Maureen, I'll kick it over to you.
Awesome. Thanks, Britt. Yeah, thanks everybody for spending some time with us today. We're excited to test out this new live event platform. So a little different than our typical, going through a bunch of slides and things like that. So we kind of thought it'd be fun to a little bit pretend like we were sitting around, the proverbial campfire telling some quote unquote ghost stories. So, just trying to play up the theme of this time of year. So we've all got a handful of different stories we're going to talk about, have some conversation. Obviously, as Britt said, we'd love to get some questions from you guys, or heck, if you have an example or a quick little tidbit that you want to share in the chat that we can let people know about of a great find that you've had with ultrasound, we welcome that as well. So we're just going to kind of go through the day, just sort of talking with you all and answering any questions, and kind of go from there. And I don't know if Britt said, but this is being recorded. So if you've got to pop off early, this will be available on our YouTube channel to watch later. So I'm Maureen Gribble with UE Systems, and been around the block a little bit. So I've gotten to hear a lot of cool stories from the field and even just talking with customers. So I'm excited to be here today, and I'll let Ryan introduce himself, and then we'll go around the room.
Yeah, hello, my name's Ryan, based out of Iowa, regional manager, so I provide for the Midwest Territory. And yeah, as Maureen said, just happy to be here and go through this event.
Awesome. Hey, everyone. My name is Alex. I am based out of Houston, but I am the account executive here. I lead all the new projects with our newer solution, the On-Track Wireless. So I'm really excited to talk about some of those cool stories later on during today's event. But I am super excited about this. I think this is going to be really fun. And thanks so much for being here. I'll pass it up to Chase.
Uh-oh.
Bingo. Here we go. Thanks, Alex. I'm Chase Sasser, regional operations leader with the Southeast team, and nothing short of supporting global footprint with UE Systems. But yeah, no, it's just a great new kind of look and avenue to have a live event to share some of our stories that we've picked up along, for myself personally, 13 years of working with UE Systems. So, Maureen, back to you.
It's been around the block, that's for sure. All right, awesome. Well, I'm going to kick things off. So I've got a pretty cool story to tell. Actually, one of Ryan's customers, but I think most of this fun stuff happened before Ryan joined us. But it's a company called BioKiowa. They are a pioneer in biotechnology, and they've been around since like the early 80s. They produce amino acids and things that go into nutritional supplements to pharmaceuticals. So they have to have a very well-run, sophisticated operation. They've got high-speed rotating machinery that runs around the clock. And one day they were doing a routine vibration route, and the technician noticed something a little unusual. There was a faint, ultra high frequency noise that was coming from their massive 1,250 horsepower recirculating fan. So pretty big piece of equipment there. And that fan was connected to a high-speed gearbox. A setup that, you know, diagnosing the exact issue was going to be kind of like finding a needle in a haystack. So the vibration analyst hinted that something definitely wasn't right. Something was going bump in the night, if you will, but couldn't exactly tell which bearing it was that was going to be failing. So they knew they needed to bring in another technology that could hear what vibration couldn't see. And of course, that's where ultrasound comes into play. So they reached out to us and we got them hooked up with our UltraProbe 15,000 as well as our UltraProbe 401 grease caddy. And so with the 15,000, they were able to actually go listen inside that gearbox and pinpoint the actual bearing that needed to be replaced. So that early detection gave them that time to plan and schedule that repair so that they could do that on a scheduled shutdown rather than having a catastrophic failure that could have halted production and potentially, you know, caused any potential safety hazards, things like that. So that was a really great success, and they didn't stop there. They knew that, okay, we now recognize that this ultrasound, we can trust it. It's provided us exactly what we were looking for. So let's take it to the next step. So they began running lubrication routes with their 401 grease caddy and started proactively monitoring the condition of those bearings and lubricating them based on condition as well. They had great success with that, which was really awesome. And then from the success they had on the rotating equipment side of things, they knew that they also wanted to take a listen to their steam traps and also do leak detection. So a lot of times, and we'll have some stories later, we'll see people kind of start with kind of the leak detection and build their program from there. But this time they knew bearings was where they needed to start, and then they added on. So they were able to then use the UltraProbe to do steam trap testing. And they found about $176,000 in failed steam traps and another $86,000 in compressed air leaks as well. So altogether, they were able to uncover about $262,000 in annual savings, which more than covered 10 times over the cost of the technology that they invested in. So super successful story, able to take their team from being reactive to very proactive in their maintenance processes, taking that guesswork out of their greasing, and, you know, realizing that ultrasound doesn't just find problems, but it can really transform a maintenance program, and just shows how you can build upon the success of one area and add it to other parts of your plant. So that was a really great case study that we're really excited about. And obviously they were thrilled to share all that great information with us. So we appreciate that. So with that, hey, Britt, we have some polls because it would be interesting as we've kind of kicked off here to learn a little bit more about who we've got on with us today and where they're kind of at with their ultrasound journey. So I think our first poll is we just kind of want to know who out here is already using ultrasound and who isn't quite using it yet. So we'll give a second for you guys to participate in that. Looks like we've got pretty much full ultrasound adoption here with our attendees, which is, oh, we got a couple folks not yet. So hopefully by the end of this, we'll have a lot of people raising their hand that ultrasound is something they're interested in tackling. Awesome. All right, cool. So Britt, maybe next we could, now that we kind of know who is using ultrasound, it would be cool to know in terms of like rotating equipment, like the great example we just shared, who is using ultrasound on rotating equipment, keeping those bearings in check. I like the font you use too, Britt. It's very on brand with our spooky season. All right, so we got about 80-20, a lot of folks using ultrasound on their rotating equipment, which is great. Bodes well for what Alex is going to be talking about in a little bit. Awesome. All right, and then let's also find out if you're just simply monitoring your rotating equipment with ultrasound, but who is actually doing ultrasound for lubrication. That would be kind of fun to see. I think we've got a poll for that. Yep, there it goes. All right. It's kind of teetering in the almost kind of the 50-50 range. So that's interesting as well. Awesome. All right. Well, I am going to turn it over to Ryan. He's got a pretty cool story he's going to share from one of his customers. So Ryan, what you got?
Yeah, so a local customer of mine reached out because their technician was out doing an inspection on their equipment. So they use ultrasound for inspections, lubrication, all sorts of testing. And they had a series of gearboxes as part of their production plan, and all 5 were the same setup. So what we call it is comparative testing, which most mechanical people do naturally. Is why do I have 5 of these gearboxes and this one sounds different? So the technician didn't really understand what they were listening to. And I'm going to play the audio so you can hear it. Let me know if this plays well. Is that coming through? If you're unfamiliar with what bearings sound like, you can hear a little bit of the bearing in the background. There's some rotation happening there. But you're also picking up kind of an odd electrical sound. So the technician didn't know what he was hearing, and he just reached out and said, hey, something's different with this one. So we actually went out there because he's close. I went out there and took a listen myself, and yeah, there's kind of an odd thing going on there. So we took an audio recording, and we used our spectralizer software and found that we did have some 60 hertz frequency harmonics, which would indicate there's some electrical in there. But it's a mechanical gearbox, and so that was very odd that we would have stray voltage going through a gearbox. So we did a bunch of diagnosis and ended up, they sent the motor to Hupp Electric, who's our local motor shop here in Cedar Rapids where I'm at. And Hupp tore down the motor, found out that internally the center ring on the motor had actually failed, cracked. And so the electrical circuit was bleeding out into the structure. So just by doing the regular inspections and listening to their equipment and not even having a ton of information, just finding something that didn't sound quite right, they actually found a damaged motor that they were able to fix and repair before production shut down, that lost time, or more serious events where maybe that voltage gets out and causes an injury or causes damage to the facility. And that was just kind of one of those highlights of ultrasound being a very good tool for all-around applications and simple procedures to really discover things before they cause problems.
Awesome.
And I'm a little bit of a, any questions about it? But yeah, just very quick and to the point with that.
Yeah, no, I appreciate that. That's great. All right, Chase, I think you've got a couple.
Yeah. So I've got one that's more like one of those, it's one of those aha moments. So 13 years ago, for any of those on the call that are on the live video here that know Mike Narrow, he's one of the greats that has helped carve what UE Systems is today. He was giving me training, and we were going out. It was like one of my first demonstrations, and we go to this. A lot of the facilities that that we get to go to are not on the right off the side of the interstate. We're off on a beaten path, maybe 2 or 3 turns left on a dirt road, and we come to this concrete manufacturer, and we're getting out, going in, and they're wanting to see the UltraPro 201, which, you know, it's one of our, you know, I would call it a starter kind of kit to bearing lubrication, that sort of thing, kind of get your feet wet, that sort of thing. You know, you're not trending full blown with that piece of equipment. You know, it's only red LED lights that illuminate up and down. So, you know, we're getting out, and they're like, all right, let's go out and test this thing. Let's see if it works. So we're going out and walking over here with our steel toes on, walking through, you know, past all the burn piles that are happening out in the middle of nowhere. And we get to these, like, they're basically air handling motors that are kind of belt driven or whatnot. So anyway, Mike puts the magnet transducer onto the side of the bearing housing, and then he's like, "Here, I need you to listen to this." So I'm put the headset on. Then Mike, we have a splitter, so he lets someone else, like, there with us that are, you know, so that they can listen as well while we're putting the grease in. All of a sudden, you know, we're sitting there yelling because, you know, you have to have PPE on, so it's like extremely loud regardless. You know, you can't just sit there and talk to each other. Well, all of a sudden, Mike says, "Hit it!" So the guy starts greasing that piece of equipment, and all of a sudden, like, we had all the lights illuminated on the grease caddy. So, like, I mean, it's actually extremely loud in the headset, but as he puts the grease in, like 5 or 6 shots go in, every single LED light disappear off of the thing. And then audibly, you're able to, like, hear normal conversation around you. So I looked at Mike, and I didn't know what ultrasound was, or what, you know, what this friction stuff was. I'm like, "Hey, what just happened?" And Mike looks at me and says, dead in my face, "We got bigger problems than bearing lubrication on this one." And I was like, what does that mean? Well, thinking back, like, now, you know, alarm levels that we have established at like 8, 16, 35. Well, we were well above, like, the 35 range. And I didn't know that at the time because I hadn't even been through level 1 or any training or anything like that. So, but once, like, hearing that, like, hearing and seeing the decibel drop was like my aha moment of, like, my God, this stuff does work. Like, you know, so it's you know, you're not out here just talking theory. And, you know, I've done countless conversations and presentations at conferences and things like that. Like, you know, one of the best conferences out there, Ultrasound World, right? So, like, you hear these conversations about it, but then you don't get the practicality of, like, having someone on site. And I do have, you know, I know that's just a story, but here in just a moment, I've got a video of something extremely similar, just with a different piece of our equipment that I can share. So, but yeah, the aha moment for me in ultrasound 13 years ago at that concrete manufacturer with none other than the legend Mike Narrow. So,
yeah. Well, and I think that was really good for you to have so early on, because I think then as you've gone out with customers, that's kind of the first thing you're always trying to get them to do, is have that same aha moment for themselves, so they can really hear, like you said, we're not selling witch oil or snake oil or whatever the saying is. You know, this technology actually does do what we're telling you it does.
Yeah, definitely. I think Lauren might have typed something in over there. All right, so getting into my my second one. So, like, kind of the gateway experience to ultrasound a lot of times, you know, years ago was leak detection, right? It's like one of the easiest things to do. It's easy to show your ROI. You know, you just capture your decibel at a X distance, and then you can show some sort of, like, numbers and figures to help you, you know, sell to management, like, hey, this is the reason why we purchased this. Here's our ROI. Let's try to do some other applications that, you know, one of the other 5 major applications that we can utilize ultrasound with. So, but I was at this company was an aerospace company. They made parts for one of the largest airplane manufacturers in the world. And when you're dealing with parts like this, you got to use a certain, type of gas. So specialty gases in aerospace is obviously a big deal. So this person had huge argon tanks on the outside of the facility, because that's what they use to weld these parts together. And all right, here we go. Air screen. This first one is this is one of our oldie goldie. This is one of our oldie goldie old school leak reports. I don't know if anybody remembers this style.
We love a relic.
This is from 2015. So this is I guess 3 years into the job. So this was back before we had like an app. I don't know if anybody uses that for their leak reports or anything, but we've got an extremely handy one now where you don't have to write everything down and stuff. But either way, this was in Florida off the East Coast, somewhere close to where we launch rocket ships, not at that place, but somewhere south of there. But we found out that the cost of their argon is basically $34.76 per 1,000 cubic feet. And I walk into their shop area, and we spotted essentially 2 leaks immediately right away. One of them was on a quick disconnect right at the piece of equipment, like right where, say, the tool kind of connected into with the welding. And then also kind of just downstream from it was a pipe thread leak, essentially. So someone didn't actually screw the connection on when they were putting the fitting on. So, but these totaled, both of these together totaled $82,000, just north of $82,000. And that, that to me was like mind boggling. Like, I had to call the office up, and I was like, hey, can we go through this number like real quick? Because I'm having a hard time believing this. And they're like, no, this is it. This is the real number. As long as your cost, or not your cost per kilowatt, but your cost per your 1,000 cubic feet of argon, as long as that's in there correctly, like these numbers are getting you close to the estimated cost avoidance. So this to me these 2 leaks are the biggest that I've yet to find, even with the new wave of acoustic cameras and everything coming out these days. This still is like the breadwinner as far as the most I've ever accounted for in one shot of a leak. So yeah, I guess with this, especially if your facility has specialty gases, anything other than compressed air, definitely give a quarterly scan, that sort of thing, while you're doing your ultrasound checks. So, all right. So the third one here. So I've got 2 more. More examples here, and this one is actually a case study that or a use case that we actually have on our website. So anybody out there that would like to look at this one is an electrical find. Now, I'm not going to sit here and snooze fest everybody with all the technical details, but you can find it. It's the title of this one is "This Automotive Company Utilize the Power of Ultrasound to Mitigate Operational Risk and Enhance Safety in Their Production Facility." So essentially, they were using this piece of equipment, and actually, this was just a demonstration. I was called out that this company was interested in looking at using an acoustic camera, or even using ultrasound in general, just for like leak scanning, touching bearings, steam traps, and as well as electrical. And we just walk into this facility, had a really nice, it's a brand new facility, really nice air conditioned area, pressurized room, as most, MCC rooms typically are. So this image on the left right here, the one with the we call it a heat map, even though it's not showing heat, but this showing the concentration of where the ultrasound is coming from. All right. And then the one on the right here is post fix. Okay. So with this equipment, I went in, obviously I recorded a sound file. So just kind of a snip from the 10-second sound file that I took. We were able to overlay it in our spectral analysis software, and essentially you're able to put up harmonic markers. So I put it on 60 hertz. So these larger bands here were populating at right at 60 hertz, which that's anybody that's ever done any of these scans, that is the dead giveaway number. If you're in the United States for like an electrical anomaly being present. Well, then as you kind of look at the sound file over here in this area, the harmonic markers kind of like they double up, right? So meaning that essentially meaning after I put a couple other harmonic markers up on the screen, it confirmed that it basically was mechanical vibration. So normally you can get that in like MCC rooms with a nameplate or a bolt that's not fastened on the cabinet. You know, it's not fastened properly. So after recording this, analyzing it, sending it back to them, I was like, hey, you know, this, you know, it audibly, when you were looking at it, the acoustic imager was saying, hey, you know, this is definitely something that needs to be addressed, you know, probably sooner than later. So after I give the report back, about an hour after I left the facility, they went ahead and diverted power and shut this thing down. And scrolling down just a little bit further, this is what they saw after. So what we've got here is, you know, we're looking through the grate. Okay. So the front grate here. So this wrapped red wire right here that's kind of right next to the red circle, this wire was not wrapped in red. It was uninsulated, and it was actually touching basically the bus bar area right here in the back. And kind of zooming in a little bit, you could see that like these plates are actually getting welded together because that wire was actually touching this this area. So it was actually, the wire was giving a mechanical, the mechanical vibration sound waves embedded inside the electrode, because it was vibrating and touching the metal bus bar there, and also creating like essentially an arc. So and tracking. So, you know, it's sitting there melting this this metal plate that's inside this electrical transformer, and this was a 13 to 8 kV scenario. So this is to date, this one was one when you're scanning and listening, it kind of made the hair on the back of my neck kind of stand up. So it was like extremely nerve-wracking. You know, again, Mike Nero can tell you, I'm not one that really likes standing around whenever I'm in an electrical anomaly situation. I like to scan it, get what I need, and get away from the situation. So, but this was a really good one. You know, a lot of times these transformers, 13.8 kV, you know, they're typically, some of them are basically built to spec. So this one, I believe, is one that takes 8 months to build. And yeah, they were able to find this one immediately. And since then, this company has gotten their own piece of equipment and doing essentially their own kind of quarterly in-house scans. So on top of their yearly IR scans and things of that nature. So yeah, no, that's the electrical. That was one of the best ones I've ever come across. But again, if you would like an example of this, or to read the full overview and summary and kind of some of the estimates that we saved on the downtime, it's the third case study down from the top on the case study tab. So, all right. And last but not least here, Alex, we'll let you go here in just a second, Alex. Sorry. All right, so this is a video. I went to a paper facility yesterday, actually, and a lot of times over the years we get some of these examples, and very rarely do we have this the ability to actually record what's happening. So we were out there using the 15,000 to do some training, and again, similar to my aha moment of at the concrete manufacturer facility with Mike Nero. This is a similar situation, but just a little bit visual of, hey, this is a pillow block bearing that we've got the transducer on here in the background. Obviously, we had to take off the guarding or whatnot to get to, but you can see the gentleman here, the lubricator, he's got a battery operated lubricating gun. And you'll notice, like, as I hit play here in just a moment, you'll see when the grease is going through the tube, because this tube right here in the background, it's vibrating violently. Okay. So that's the grease going into the tube, and then you'll see the decibel react. But if anybody out there, like anybody in the chat, if y'all got like any videos of something like this, hit a 1 in the chat or reach out to me. I'd love to see what you've got as well. But here we go. I'm gonna hit play for us. So in that video there, obviously what was happening is you put some grease in, the decibels dropped, had an extreme drop off, and whoever was holding the piece of equipment there, they were, this is their first time experiencing this. I sat in the room and trained them before, on what we should be listening to, and then all of a sudden he's just wow, like he couldn't believe it, because he's having this aha moment, just like, so it was great to have, to be able to share that moment with somebody else. It's like, hey, this is what I've been talking about. And I did, 5 minutes after we went back to this piece of equipment, and actually the decibel levels rose back up. So, we got it down to, what would be considered a baseline, but it didn't stay down. So kind of giving them the indicator, hey, this is probably where they need to be planning and scheduling on their next downtime scenario. So, but those are some of my, some of the things when I was asked to kind of come on this live event here, like, those are ones that really just immediately, the lubrication, the aha moment, your largest finds, the electrical, scenarios, like ultrasounds. It does multiple things, and it's great at it. So, but all right.
I love it. I love hearing that guy.
Alex here.
I love hearing him say "wow," hearing that guy get his aha moment in real time.
Wow! Wow! Yeah, no, it was fun.
I thought it wasn't anything we had to edit out. That's great. Awesome. Well, yeah. So, Alex, you've got some cool stories to tell as it relates to our newest solution, the on-track wireless. So we'll let you tell your spooky tales.
Yeah, not too spooky, but they should be surprising. But I think all of my colleagues so far have talked about some of our legacy solutions, some of our legacy products that have been around and been staples in a lot of facilities across the globe, really. But I get the really cool opportunity to talk about one of our newer solutions, the on-track wireless. So this is kind of what we see as the future in being able to monitor and lubricate your bearings. So even in the short amount of time that this solution has been kind of out in the wild or on the market, we've seen some really great results and we've been able to get some case studies done. So just like Chase said earlier, you can go on our website. I think we do a really good job of collecting a lot of learning material that you guys can just download and review. So you can see all these stories that I'm going to bring up here in a second. But I'm going to pull up, give me a second. I'm going to pull up my screen so you guys can see what we're talking about. And it's not this cute guy right here, but let me get this going. All right, can you guys see my screen?
Yep, we got you. Yep.
All right, perfect. All right. So for those of you that aren't familiar with the solution, here's our on-track wireless. It is essentially an ultrasound, vibration, and temperature monitoring sensor that allows you to communicate with a single point lubricator to provide autonomous lubrication. So not only have we been providing ultrasound solutions for the past 50 years, but we've now added in vibration and temperature to this really great system. And so we did, and we still do have a wired version that's on the market and still providing a lot of value. But like I said, this solution in itself is just over 2 years old, so still pretty new, but a lot of great results from it. And what it does is really allow you to be predictive and at all times have that peace of mind knowing that you're going to get great data coming from that sensor and then be able to lubricate. So one of the first ones that I'd like to discuss is about time-based lubrication, right? And our entire approach at UE Systems is conditional lubrication is kind of the light, right? It's the way that we want to have all of our partners or the path we want them to go down, because we see that as being the most beneficial and allowing facilities to really extend the life of those bearings. And so what we did was we partnered with a company that had a facility that allowed us to install the on-track and really test that fact or that notion that time-based is better or equal to condition-based. And I'll be, completely transparent with you. There are a lot of applications or a lot of pieces of equipment where time-based is going to be all it needs. Time-based is going to be great for it. But for some of those critical applications, we see the on-track as a great fit for that. And with this specific example, what we did is we added the sensor and the lubricator to an application, and we said, hey, let's see what the readings are going to show us. And what they were previously doing was adding in lubrication once every 3 months, right? So pretty much once a quarter, they'd go in and they would add in an arbitrary amount of grease to the bearing, and they say, all right, well, we'll see you again in 3 months, right? So what we found was that within the first 30 days of monitoring the data from our on-track, we saw that there was a lubrication threshold being met, and that was set up by our ISO standards. We know exactly when we need to add lubrication, and then the system also tells us when we need to stop adding lubrication. So what we also found was that not only were the intervals that they were adding grease too infrequent, it was also too much volume, right? Because we found with just 3 cc's of grease, that brought that decibel level, that friction rise back down to the baseline of where it should be. So in just 30 days, we're able to pull out some really good information to show, hey, we need to add a lubrication at this time, and the correct volume made it a precision lubrication event. So that was a cool success story. All right, we got another one right here. So like a lot of facilities, environment can be an issue, right? And whether you're working in, Eastern Canada, where it gets frigid for half the year, or you work in Texas, my home state, where 112 days is not that abnormal, right? So we're working with a facility, and they are dealing with these fans that have to deal with extreme heat. And what they were finding was there's been a lot of issues with failed bearings, and they were also on a time-based lubrication kind of method at that facility. And they said, we want to find a different solution and find a different way. So they tried out the on-track, and we were able to pull data from our short time monitoring the system. And what we found was that we put it on the drive-in and non-drive-in, a sensor and a lubricator. And for some reason, the drive-in would take exponentially less grease than the non-drive-in. And just normally in everyday kind of lubrication, you'll see small deltas in your variation of how much grease is needed for one piece of equipment versus the other one, even if they're doing the exact same kind of task or in the same area. There should be a small variation, but this one was exponentially bigger. So we're like, why is our non-driving requiring so much more grease? And so from the data, the maintenance team at the facility said, hey, let's do a root cause analysis. Let's see what's going on. And they found that non-drive-in was recently replaced and it wasn't installed correctly, right? It was off balance, which was causing some looseness. And that in turn was increasing the friction level and allowing that situation to where it was asking for more grease when grease wasn't necessarily the issue, right? So not only were we able to detect that something was wrong, we were also able to detect it wasn't a lubrication issue. It was improper installation and looseness and some other downstream issues. But that was also a key piece that we found. So not only can we optimize the lubrication piece, we can also tell you what the issue is not, right? So that helps you out, because then you go down that line of, canceling out what it could be, and then ultimately you get to your goal and be able to predict some of these issues. All right, one more, and I'm gonna start this one off with a little caveat. We are very, very firm believers in vibration here at UE Systems, right? So obviously we believe in ultrasound, but we see a lot of value in vibration and vibration analysis, and that's why we've incorporated it into our sensor, right? But in this particular occurrence, we found that ultrasound was able to find bearing faults before the vibration data was able to tell anything was wrong. And what was happening is that, and I'm sure you guys have all seen that P to F curve, and you know that ultrasound is going to be at the tip of the spear when it comes to being predictive. But we saw that as soon as we added our sensor to that asset, we saw that decibel level started to rise and go up, and it called for lubrication. So it hit our standard lubrication thresholds. And what we did was we started adding in lubrication. But because it was conditional lubrication based, we saw that there was no change in the friction level, right? We still saw a high decibel value, which means that, hey, it's not a lubrication issue. There must be something else downstream, right? So what we found was that it was a vibration issue, and we had faults inside that bearing that it was way past the level of lubrication pretty much. But for the sake of the case study, what we did was we continued on with the trial, or trying to figure out what was going on. And it wasn't until over 30 days that the vibration analysis found that something was wrong, way past when ultrasound saw that there was a change. So that was really, really big, and really good to be able to validate that ultrasound can pick up, even if it's not going to give you exactly what the diagnosis is. It can pick up some of those small issues way before they become big issues. And I think that's the big goal. And so as this solution of the on-track grows, and as it matures, and we add in new features and new benefits, I'm sure we're going to see a lot more success stories like these that I've just covered. But like I said, there's going to be a lot of information on our website that you guys can look at some of these case studies and some of these information that we've covered. But I think that it's going to be a great system and a great solution. And if you guys ever want to discuss it, please reach out, and we can figure out if it's a good fit for you.
Awesome. That was great. Thanks, Alex. And remember, if anybody has questions, they can definitely be tossing them into the chat. So I've got another one. So this is from a food and beverage facility. And what kind of started out as a routine leak survey kind of turned into something a lot bigger than that. So the technician was walking around with his UltraProbe 10,000. That's what they had. And he was doing a leak survey, headphones on, scanning around, listening for that hissing sound that the leaks emit. And all of a sudden, though, he heard something that he was pretty sure was not something he should be hearing. A sharper, more erratic sound that didn't seem to belong in the environment in which he was in. So instead of just continuing on with his leak survey, he decided, okay, I need to investigate this further. So he took the 10,000 and he started scanning around over by some electrical assets, and he realized that is exactly where that sound was coming from. So with his 10,000, he was able to record a sound file and do some analysis. And sure enough, what he thought from just the sound signatures and being familiar with it was true when he did the analysis, that there was electrical tracking that was leading to arcing happening on the bus bars. So he had that information at hand. He decided to get a second opinion, if you will, by using his infrared camera. And that certainly confirmed that heat and corrosion was present. And so they were able to make a plan to immediately repair that asset. And, I guess the moral of the story here is, that moment of curiosity and being able to hear what otherwise you wouldn't be able to, they were able to turn something that could have been a serious incident into a repair that was able to get done in a timely fashion. So, this simple leak survey turned into a life and equipment saving discovery. Just another kind of example of the early detection that ultrasound can provide, especially when it comes to electrical scans. And I know, Alex was just talking about vibration and ultrasound, and now I've just kind of mentioned infrared. What is great is the more that you can have these different technologies complementing one another is always going to be a really great way to add to your toolbox. So interesting story there. And actually, I've got the sound file. I wonder if I can play it without just sharing my screen. Let me know if this comes through. So that's what that sounded like. And then I can share my screen here just to show the pictures. So this is what that sound file looked like. So you can see those peaks and you can see that tracking happening. And then this is what those bus bars looked like when they went in to repair them. So a really good catch there for this customer. All right. And then
to tag on with you, Maureen.
Sure.
That is something we often talk about as the regional support guys when we go out and do those trainings, is to use those technologies hand in hand, because they all have a strength that they can help isolate an issue, and then those other things can come in and be beneficial. So vibration, ultrasound, and thermal all work very well together.
Yeah, no doubt. So kind of the final story that I've got, another one of Ryan's customers. Ryan, I don't know why I'm telling all your stories, but this I think also happened pre-Ryan. But this took place in Dubuque, Iowa at a Rousselot facility. So they are producing gelatin and collagen ingredients there. And quite a few years back, their maintenance team was frustrated. They were having unplanned downtimes. They knew they had costly air leaks. They had failed bearings. They knew their steam traps were not functioning as intended, and that there just, had to be a better way. However, like I'm sure a lot of you guys have experienced, the idea of bringing in something new is always going to be kind of daunting, because not only are you putting out, spending money, but that anytime you're bringing in a new technology, somebody has to do it. So there's work being added, et cetera. So all the typical excuses, but they did decide, well, we've got to do something. We cannot continue to just sit here and let these problems happen. So they decided to start small, and they came to us and they purchased our UltraProbe 3000, an oldie but a goodie, to do compressed air leak surveys. And they quickly found that they were finding enough leaks, not only finding them, but tagging them, fixing them, and reporting on the savings that they achieved from doing that. And so that more than covered the cost of the equipment, and it got them the buy-in and the excitement and the enthusiasm to move their program on to the next application that they wanted to tackle, that they knew they needed to tackle, which was their bearings. And so they then invested in our UltraProbe 401, and they began doing condition-based lubrication as well as routine trending of their bearings. And through that, they found 34 failures that they were able to address before they became actual breakdowns, saving over $150,000 in repairs and about 42 hours of downtime. From there, they then invested in the UltraProbe 15,000. They knew that steam traps, as I said earlier, they knew those were causing them grief, and they also wanted to do electrical. And in order to do electrical, you do need, either the 10,000 or the 15, or now one of these acoustic cameras. So they invested in the 15, and when they went and did their steam traps, they found 23 traps that were failing, and that was another $34,000. And then from the electrical side, they detected arcing inside a critical breaker, and that breaker would have taken 5 months to replace. So much like Chase's story earlier with the long lead time for replacement parts, this was a huge catch for them. They said that if that had actually failed, it could have been a $1.2 million disaster. So crisis averted there. And so they continued to also do their leak program. They had found over $160,000 in leaks with their UltraProbe 3000, giving themselves enough, ROI to encourage the purchase of an acoustic camera, one of the first ones that we supported, the UltraView, and that boosted their leak findings by 400% in 4 months. So that was pretty awesome. So I just really love their story, knowing that they had problems, recognizing it, knowing that there was something they could do to improve, starting small, and then expanding that program out. Yeah, what's up, Brian?
So I worked with Alan to create the case study and done a lot of things with them. A couple of great things is that case study I use a lot to show people what they can do with an ultrasound program, because he does every application and he breaks down how he sees the ROI. With, as you said, the reduction in production downtime, reduction in parts being needed. One of the things he doesn't have in there, but I highlight a lot, is at their facility, 95% of their repairs are done during a scheduled shutdown. They have very few things that break during production and cause an issue. So everybody's production time is worth a little bit different money, but just being able to say that 95% of the time we're able to make a plan and get it fixed without it breaking down during production.
No, that's awesome. Yeah, and it's, they say on here that their ultrasound program has contributed to about $2 million in cost avoidance. And I know that cost avoidance, when we talk to people, is always kind of a tricky thing to try and figure out how to kind of calculate. How do you determine how much something didn't end up costing you? But we actually did a webinar last month with Milan Henninger. He's been a longtime customer and friend of UE Systems, and he's got a really great way of kind of breaking that down. So if you're interested in that, definitely hop over to the YouTube channel and find that webinar. That was really cool. Or of course you can reach out to us so we can share some of those calculations that he uses. But yeah, the taking these successes, and that's one thing we stress all the time too. It's one thing to gather these stories and to have these great finds, but you can't keep them to yourself. You've got to share them. You've got to celebrate them. You got to make sure the people up top, the bean counters, as it were, are aware of these great savings and the successes. And of course, the more that you celebrate all that, you get those champions then who really want to embrace the technology and keep a program moving in the right direction and growing from there. So that's our stories for today, guys. We really appreciate you taking some time with us this afternoon. Hopefully something piqued your interest. You heard something that might be, you kind of like, oh, I think I've got something like that going on at my facility. But we would love to chat with you further about it if that's the case. We do have a couple questions here. It looks like mostly we're curious, and Alex, I'll throw this one to you, about the plans of integrating AI in the future into our roadmap. Maybe you can speak to that.
Yeah, absolutely. So obviously that's the way of most technology right now, and we do have a plan for that. So we're calling it LEA. So it's lubrication. It's a lubrication event where we're learning over time the frequency and the different patterns of your applications. And so AI is going to be heavily involved with the frequency in which we add grease, and the entire system is meant to automate and be able to give you next level changes. So AI is definitely on the horizon.
Awesome. Yeah. Okay, cool. So I just want to put a little shout out. We do, and I know, Britt, you're going to throw up a slide here. We have a couple more of these live events scheduled through the end of the year. Do want to do a little call out for some help on our next one. You'll notice a theme here. We're really digging in on the holidays. But for November, we really want to kind of talk about all the ways we can kind of give thanks for what ultrasound can do. But more importantly, we want to use it as a platform to kind of give thanks to you guys, to your technicians. We want to use it as an opportunity to do some actual shout outs for some really great ultrasound users. And if you've got folks that you want to highlight on that, we would love for you to share those folks with us, a little story about them, maybe the photo, so we can kind of do a little Thanksgiving celebration next month on our next live event. So more to come on that. And yeah, with that, Britt, I think we wanted to also showcase our latest and greatest offering, which is our new e-commerce site. So we'll kind of end on that. But Britt, any last minute thoughts?
Yeah, no, thank you guys for joining. I think that was super fun. I love hearing all the ultrasound stories continue to uncover those issues. So like Mo said, we have those two coming up November 19th and December 17th. You can register at the one spot. And then last but not least, we're going to turn it over. And if you haven't seen or watched any of our social medias yet, you will see that we have launched our new e-commerce. So we're going to share this video, pulling it up. And then we hope the rest of you have a great rest of your day.
The next generation of UE Systems is here. For decades, we've helped industries around the world listen closer, work smarter, and build reliability with precision. Now, we're redefining how you do business with us. Introducing our new e-commerce platform, a seamless way to explore, compare, and order the tools that power your reliability program. Simple, transparent, pressure-free, built for convenience and confidence, putting you in the driver's seat. Because innovation isn't just in what we make, it's in how we make your experience better. The future of reliability starts here. Visit shop.uesystems.com and discover the next era of UE systems.
And with that, have a great day, everybody. We'll see you next time.
Bye.
See ya. Bye.
Happy Halloween.
Happy Halloween.